Welcome back. Here are some notes on evaluating variable expressions now that we've done a warm-up on order of operations. So evaluate. Evaluate is a verb and it means to input a value and simplify. So by input a value, it means when you have an expression that contains a variable, that variable or that image is a placeholder for anything that you want. You can plug in a number here, you can plug in another expression, you can plug in another variable, you can input whatever you want wherever you see a variable in your expression. And then simplify is just a fancy way of saying do the math. Do the adding, do the subtracting, the multiplying, dividing, do as much math as you can until you get down to the end and you're like, I can't do any more math, I must be done. And that's called your answer or the value of the expression. It sometimes has different names. So here we go. Let's go ahead and write down these 4 examples. So we have example 1, x minus 5, example 2, x plus 7, example 3, 4x, and example 4, x divided by 3. Now, I purposely chose these examples because I chose examples that were, one of them is a sum, a difference, a product, and a quotient. Can you see which one is which? Which is the sum, the difference, the product, and the quotient? Let's see. I think in number 1, because I see a subtraction symbol, that means this is a difference. Yes, we would call this expression a difference, x minus 5. Number 2, because I see an addition symbol and I'm saying the word plus, this is a sum. So we have number 1 is a difference, number 2 is a sum. Which one's the product and which one's the quotient? Well, what I see in number 4 is I see a fraction bar, which I now know means division. A fraction bar is a way of saying a division symbol. So this one must be our quotient. Anywhere time you see a fraction bar in a variable expression, you think quotient, which leaves us with the product for example 3. Now products are a little bit weirder with variable expressions because you don't see parentheses, you don't see a dot, you don't see anything, you just see a number next to a variable. This means 4 x's, which means 4 times x, or we could just call it 4x. So we have our difference, our sum, our quotient, and our product. Let's go ahead and start evaluating. Now we could technically pick any number that we wanted, and then as soon as we pick a number, we're going to input that value, and we're going to do the math. We're going to simplify. So let's say for example 1, I decided to input 7. Well, let's see here. If I chose to input 7, then the math is pretty easy. Wherever you see an x or variable in the expression, we're going to replace it with the number 7, and then we're going to simplify. We're going to actually do the math. So now instead of x minus 5, we're doing 7 minus 5. And 7 minus 5, well, let's do that math. 7 minus 5 is, I believe, 2. And we can't do anything left with 2, so we are done. We have now simplified the expression when x is 7. Now 2 is unique. You can only get 2 by substituting in 7. If you picked another number, any other number in the world, and you substituted it for x here, you would not get 2. I challenge you to try to find one. So pick any other number, -7. You won't get 2. That's why that value is unique. Let's try number 2. Okay, so this is our sum. We're going to pick a number for x, and then we're going to add 7. Let's say, just for fun, let's pick a negative. How about -10? Let's input -10. We could have done anything. I just chose -10. So here we go. We're just going to input wherever there's an x, we're going to plug in or input -10 instead. Now we're going to add 7. Now careful here with negatives because our brains see 10 plus 7 and we think 17. But you have to be careful. This is -10 plus 7, which really means if I have 10 negatives and 7 positives, those are not going to, that's not going to make 17 negatives. That just doesn't make any sense. So there's 2 ways of thinking about this. I'm either starting at -10 and I'm moving 7 to the right, or adding a negative is the same idea as subtracting. So you could also think of this as 7 minus 10. I don't know which one works for you, but don't just see 10 and 7 and go 17 because that won't definitely will not work. All right, whatever works for you, -10 plus 7 is actually -3. So we would call that the value of the expression when x is -10. It's very specific. Let's take a look at number 3 now. I can plug in anything I want, but since I'm multiplying by 4, I probably don't want to plug in something too big. So let's say x is, I don't know, 5. Now, when you are substituting or when you're inputting into a product, it is important to include some multiplication symbols. In other words, if I don't include that and I just do this, 4, 5, does that look like multiplication to you? That looks like the number 45. So whenever you're going to substitute a value into a product, include some parentheses. Otherwise, it looks like you're just creating a number out of nowhere. This is 4 times x, which when x is 5, that's 4 times 5. And when we simplify that math, 4 times 5, they're both positive. That's easy peasy. We have 20. That's the value of the expression when x is 5. Now the quotients, the quotients. Now the quotients are a bit tricky. We could have picked anything we wanted for examples 1 through 3. And technically you can pick anything you want for example 4, but if you want your life to be a little easier, pick something that can be divided by 3. For example, I wouldn't want to pick 5 here because I can't divide 5 by 3 evenly. I could make it a fraction and then I could stop because I couldn't do any more math, but if you had the option, why wouldn't you just pick a number that 3 goes into? So 3, 6, 9, 12, 15, 18, so on and so forth. Pick one of those and substitute it in because then you're actually able to do that division. So just for fun, let's say we're going to plug in 18 and then let's make it a negative because we haven't done a negative in a while. So x is negative 18. Now, why did I choose that? I chose that because I know 3 goes into 18, which means I can do that math. I can actually simplify. Okay, let's plug it in. Here we go. So it's still a quotient. Now the numerator is negative 18. I'm going to go ahead and put that in parentheses just because I don't want to forget that it's actually negative. Divided by 3. And negative divided by positive is a negative. Negative 18 divided by 3 is negative 6. So we would call this the value of the expression when x is negative 18. Now these are all pretty simple examples. Let's get into something a little bit more complex. All right, some complex examples, something that's going to make us think a little bit more, maybe have to be a little bit more careful. So example number 1, 4x minus 3 plus x divided by 2. Notice that I'm only using x's here, which does mean that whatever you choose for x, you're going to have to input it into both locations. Complex example number 2, x divided by negative 5 plus 3 times the group of x plus 4. Now, remember, it only matters what you substitute in, what you input when you see quotients. So I purposely put quotients in both of these. So let's see, number 1, doesn't really matter when I'm multiplying 4 by x, but if I'm going to divide x by 2, I'm going to pick a number that's divisible by 2. 2, 4, 6, 8, 10, etc. So I'm going to pick, what's divisible by 2? How about negative 4? That sounds fun. So for number 1, we are going to substitute in negative 4 and simplify, which means do the math. If you want to try to do this on your own, go ahead and pause the video now. For the rest of us, let's go ahead and do this math. So for number 1, I'm going to go ahead and substitute in. Now I'm making sure that I'm keeping the same structure as I go. So I'm just plugging in, I'm just substituting in negative 4 for the x. So starting off with 4, put in your multiplication sign, otherwise it might look like a different number. 4 times negative 4 minus 3 plus the quotient negative 4 divided by 2. So when you substitute in, that first step should look identical. These look almost exactly the same, except for now I have a multiplication symbol and I have negative 4 instead of x. Now we do order of operations. I don't see any groups and I don't see any powers, so let's do all products and quotients. Product, quotient, here we go. 4 times negative 4 is negative 16 minus 3 plus negative 4 divided by 2, negative 2. All right, now that we're out of all of our products and quotients, let's just go ahead and simplify from left to right. Negative 16 minus 3, let's see, I'm counting back, negative 16, negative 17, negative 18, negative 19. Notice when you're subtracting from a negative, that negative gets bigger. So this is negative 19 plus negative 2. Now, do I want to change this into subtraction? Well, because they're both negative, sometimes it's easier for us mentally to keep it as adding a negative, because I'm just going negative 19 plus 2 more negatives for a grand total of negative 21. All right, over here in number 2, again, there is a fraction. I'm dividing by negative 5. So I don't want to pick negative 4. I would have to deal with fractions, and we all freak out with fractions. So let's pick a number divisible by negative 5. 5, 10, 15, 20, blah, 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 blah. How about 10? And just for fun, let's make it negative 10. So we're going to input negative 10 for x in the second expression. If you'd like to try it on your own, go ahead and do so now by pausing. For the rest of us, let's go. Okay, step 1 is pretty simple. Just input it in wherever you see it. Keep the same exact structure. So for here, I have negative 10 divided by negative 5 plus 3 times the group of negative 10 plus 4. That should be your step every time. Write the same expression, this time using negative 10. Okay, do we see any groups? Yes, we do. In this case, we have negative 10 plus 4. Again, don't just jump to negative 14. That's the same thing as 4 minus 10, or I'm going to end up with a smaller negative. So either way, that's not negative 14. That's negative 6, negative 10, negative 9, negative 8, negative 8. Yeah, negative 6. So here we go. Negative 10 divided by negative 5 plus 3 times negative 6. Okay, do we have products and quotients? You betcha. We have a quotient here. We've got a product here. Let's go ahead and simplify. Negative divided by a negative is a positive. Think about your math there. Covering up those 2 negatives, you're left with a positive nose, and that's positive 2 plus positive times a negative is negative 18. Now here, because these are not both negatives, it might be easier, because I don't know how you think, it might be easier to change this to the equivalent expression of subtraction. Some of us might have an easier time of subtracting when one of the terms is positive. So if that makes it easier for you, you can think of this as 2 minus 18. And if I count 18 back from 2, I end up at negative 16. All right, let's wrap up this instructional video. Now that we've done a couple of like minorly complex, let's get into a super complex expression. All right, here we go. Our last expression of this video, the super complex expression. Now, why is this a super complex expression? 2 reasons. I put 2 different variables in, and I included everyone's favorite fraction. But remember, a fraction, when you see it in a variable, is really just a combination of multiplication and division. So if you could do those other expressions, you can do this one. Let's get started. Okay, first thing, when you have 2 different variables, that typically means that you're going to substitute in 2 different numbers. So let's pick a number for x and let's pick a number for y. Because y is not involved in a fraction, let's do y first. So y could be anything. I'm thinking of 5. Let's make y 5. And it could have been anything. I just chose 5 for fun. So y is going to equal 5. So already you're starting to think about, okay, I'm going to substitute y here and here. X, however, is a little bit tougher because we want to choose a number for x that's divisible by 4. Why do I say that? If you really think about what this term means, so I'm just going to make a little thought bubble here. 3/4 times x really means 3 times x divided by 4. A fraction is just multiplication in the numerator and division in the denominator. So just like we were doing in our other examples, just pick a number for x that's divisible by 4 and you'll be fine. You won't have to worry about fractions much longer. So if I'm thinking about a number that's divisible by 4, 4, 8, 12, the bigger it gets, the tougher it's going to be. So let's just do 8. But because this is a super complex expression, let's make it negative 8. So I have decided to substitute or input 5 for y and negative 8 for x. And if you'd like to try it on your own, go ahead and pause the video now. For the rest of us, let's go. I get so excited with these. Okay, step 1, same expression, same structure. We're just going to substitute in the values that we know. So anywhere I see an x, I plug in negative 8. Anywhere there's a y, I plug in 5. So here we go. I start off with an x. which means I'm going to start off by substituting in -8 right off the bat. Plus 4 times the group of 3 minus substituting in 5 for y. Why didn't I substitute in -8? Because 5 for y. Y is 5. Plus, now, to deal with this fraction, let's write it using multiplication and division instead of keeping it as a fraction, because like that fraction freaks us out. So the way I'm going to write this is 3 times what I'm going to substitute for x, all divided by 4. So 3 times -8, all divided by 4. And that usually helps our brain understand and like calm down a little bit. And then don't forget about that -2 times, what's y here? Y is 5. Whew. Okay, now I'm telling you right now, I'm going to predict it's going to take me at least 5 different steps, maybe even 6 to do this expression. I'm not going to rush anything. I'm going to take my time because it's better to take your time than to be the first one done. So I'm going to go through my order of operations. Do you see any groups? These parentheses stand for products. So here's my only group. So you know what? In my first step, the only thing I'm going to do is simplify that group. Here we go. -8 plus 4 times 3 minus 5. 3, 2, 1, 0, -1, -2. -2. And everything else just comes along for the ride. I'm not dealing with it yet. All right. Order of operations, step 2. Do I see any products and quotients? Well, 4 times -2 is a product. 2 times 5 is a product. And then this is both a product and a quotient. Crazy. So in this case, I think it would be easier to do the product first, because remember, you're multiplying 3 by x, then dividing by 4. So in this case, we're going to do this one in 2 steps. We're going to multiply first, then divide. All right, here we go. So we have -8 plus 4 times -2, positive times the negative is -8. Notice that I'm putting that in parentheses because I don't want to mistake that for a subtraction symbol. Plus, this is still going to be divided by 4, but I am going to simplify that product. 3 times -8, well, 3 times +8 is 24, so that must be -24. And look at that, you're almost done with that fraction. It just turned into a quotient. Minus 2 times 5, easy peasy, 10. All right. Oh, we are so close to being done. Okay, we just have one more quotient here. Let's go ahead and get rid of that quotient, and then we're just left with integers, right? -24 divided by 4. Negative divided by positive is a negative. I think that'll be -6. So let's go ahead from left to right. -8 plus -8 plus -6. Look at those parentheses to distinguish those as negatives. Doesn't really matter in the front here. -10. All right. So we've done our group, we've done our products, we've done our quotient. Now we just go from left to right. So here we go, -8 plus -8. Again, because this is already negative, I don't want to change that to subtraction. I'm just going to total up the negatives. -8 plus -8 is -16. Plus -6 minus 10. Continuing from left to right, -16 plus -6. Again, because they're both negative, I'm just adding up negatives, which is really similar to adding up positives. -16 plus -6. 16, 17, 18, 19, 20, 21, -22. Oh, I'm almost out of room. -10. Now, this last step could be a little bit tougher because your brain sees minus, it's immediately going to jump to 12. But careful, this is a -22, which means when you're subtracting 10, you're actually going further negative on the number line. So that's like -22, -23, -24, -25, all the way until you hit -32. And that is our value for the expression when y is 5 and x is -8. And look how many steps it took us, but we took our time, we followed our order of operations, and we made sure to keep our work organized. And that is very, very important. All right, after this video, we're going to wrap up with an exit ticket going over more super complex expressions.